My name is William Gibb. I'm a coworker of Doug at Mandiant. I don't have a fancy intro slide with my name on it and whatnot. I've been with Mandiant for a couple of years, working in their professional services group, doing incident response. Earlier this year, I joined Doug with the threat indicators team. I'm one of the people that's actually working to make us going from crawling to running all the way to flying at Mandiant with our threat indicators. One of the things that Doug spoke about briefly in his presentation was OpenIOC 1.1. Previously, about 2 years ago, we open sourced OpenIOC as a standard, and Doug's already talked about what that is, but when we did that, there were a couple of pitfalls involved. We didn't publish any sort of open tools to support OpenIOC, to support reading them or writing them. When we did that, and I don't believe this is explicitly mentioned in the documentation on our website, but all the operators, we were bound to using Lucene to do text matching with our product. And that's got some limitations. Has anybody in here used Lucene for text matching? It can kind of get a little finicky, so there's some issues there. We only had a limited number of operators, so we were looking for string matches or substring matches. And for the folks that raise their hands with Lucene, Lucene doesn't really do substring matches as much as it does token matching. So we had these issues, and we wanted to toss out things that didn't work for us, and we wanted to keep things that did and build upon them. So we did a little bit of reorganization of the schema. So we added in that parameter section that Doug mentioned. That let us do metadata tagging within the individual, that let us do some metadata tagging within the individual indicator items themselves. We added in all sorts of new operators for doing matching. So again, people that used Lucene, you're probably familiar with the evils of that. Is now is for us. Contains is now a proper substring match. We added things like begins with, ends with, greater than, less than, all features that people had requested that had talked to us. We added in support for the matches operator, which is what we're using for regular expressions. The operator functionality is defined as per the XPath 2.0 specification. That's partly a technological limitation for us right now. However, it does give us much more concretely defined operators for how things behave. Whereas if you're using Lucene, that can be very painful and very Lucene implementation specific. In the same token, this OpenIOC 1.1 is a draft specification, and it is available for consumption for people to review, to comment on, to give us feedback on. That's available on GitHub, on our public-facing github.com account. Doug mentioned parameters. Since we've added these, we can add them to those indicator nodes, which are those and or logic structures that Doug mentioned earlier that we can use to add and combine terms together. Or we can add them to the indicator item nodes, which are the nodes that actually contain the threat intelligence, a file name or a file hash or a DNS name. So we can add some metadata, things like comments, confidence, criticality, things that you can use to score indicators automatically. But these also allow you to prototype things that you could use to extend the OpenIOC schema with. So if you say, I want to do a different operator that isn't in that list that I had previously, you could make that operator up on your own, embed that in the parameters section, and then you could do some prototyping and seeing how that works in your organization with your technology chain, with your intelligence. And maybe you can propose that to us, and we could include that in. So instead of us having to include the umbrella, everything under the sun with our schema, we open up this notepad, kind of like a playing field for you to develop your own tools. And actually, I'm going to show an application of this doing OpenIOC to Yara, where we can embed Yara signatures in an OpenIOC format that's nice, easily human readable, and we can extract those out and do actual functional signatures. So you're probably wondering, what's this iocwriter tool? TLDR, it's an OpenIOC, it's a Python library that allows you to build OpenIOC 1.1 objects. So you don't have to worry about building XML by hand. I've seen a couple implementations of OpenIOC in the past where people have just built their IOCs by taking blocks of text and piecing it together with string concatenation. That's really not the way to build XML or to handle it. This allows you to create your IOCs through API calls. It's built on top of the Python LXML library and supports a set of CRUD operations. So creation, updating, deleting elements is all supported. I wasn't going to go through the trouble of reinventing yet another tree data structure. So doing all of your reading, doing all of your data extraction. LXML and XPath is actually pretty efficient at taking care of that for you. And that's available up on GitHub, on our public-facing GitHub as well. So it's pretty easy to use. It's a Python library. You can install it very quickly with the setup.py file. And there are really two files that you would care about as a user. You would import the IOC API file, which would allow you to do your creation of your indicators. So that'd give you an IOC object that you could then manipulate. And then there's an IOC commons file. So Doug mentioned that we've got about 70 indicator terms that we use in reality out of about 500 or 600. Those 70 are quickly available for you to use, so you don't have to know the details of the IOC terms. And also in this library, there's a couple of examples of where this code is used. So there's a simple writer. So if you've got a big CSV of data that you want to convert into an open IOC, so you can start to contextualize your intelligence, you can use that. I've used that actually on engagements when I was looking to filter data, both to generate lists of things to match on. So if I get a list of hosts from a client, or also if I've got a list of hosts that I wanted to whitelist for some reason, that allows me to really quickly generate IOCs that I can use to filter with. There's an example, like I mentioned earlier, about Yara. So there's that code. And also for anybody that's using OpenIOC 1.1, maybe they're also a Mir customer, maybe you're using Redline to power your incident response. There's a down conversion script. So you're not stuck in an OpenIOC 1.1 world if you wanted to use OpenIOC 1.1 today to power your parts of your incident response and your intelligence sharing. How many people want to see live demos? Cool. If something breaks, don't be too surprised. Exactly. So it's pretty easy to start using. If you're a documentation junkie, the library itself actually has documentation already available and nicely auto-generated. I'm not going to sit down and go through documentation because that's boring. But if we wanted to, we could go ahead and create an IOC or open one from scratch, open one up and edit it. So I'm really kind of doing this off the cuff. So if something does blow up, don't be too surprised.
Bigger text, please.
Bigger?
It's okay, we just throw stones, that's all.
That didn't help.
No, no problem.
Enhance.
I wish.
We need layout, I think.
Yeah. Is that a little bit better?
Oh my God.
Not really?
No.
No? Well, we can imagine it here and we can pretend. We can have a pretend demo here.
Don't sit in the back.
Pretty straightforward though. You can import the code. If you've got a file name, you can open that up. That's going to give you a IOC object that then you can manipulate. You can walk it. You can extract your indicators. You can run your XPath against it if you want to extract indicators outright. Since it's built on the LXML API, if you wanted to just append nodes together, it's very straightforward to do that. You don't have to have a very intimate knowledge of the IOC schema to start to play with this. I would recommend looking at some of the example code if you want to do that. The simple iocwriter tool is actually what was used to generate and release the NetTraveler IOC that Mandiant released earlier this summer after Kaspersky released their NetTraveler report. As Doug mentioned, people release these reports, they're filled with PDFs of information. So we scraped all that text, and where we were able to structure it, we structured it into CSV documents. And then we used this tool to generate IOCs, and then we merged those IOCs together to generate what we actually released. With a little bit of hand curation involved as well. So they had a lot of terms where they had repeat information over and over again, where they could have collapsed things into a logic tree that we can do with OpenIOC that you can't do with just a flat list. I'm not going to show that, so that's just going to get messy again. If you want to integrate with other tools, this library is primarily aimed at people that are doing development or tool integration. If you've got a malware sandbox you wanted to generate IOCs from, if you're running Python, this would be a very straightforward thing to plug into your malware sandbox. If you've got like an execution report and you're summarizing files that a malware is dropping, DNS lookups that a malware is performing, C2 activity, if you're extracting registry keys, you could codify all of that, and then you can convert those into OpenIOCs. You could use this as the basis for a custom editor. I actually had another Indian employee approach me about doing that recently as a side project for themselves to learn on. If you're doing text scraping, so if you've got a lot of unstructured data, so you've got case reports, you can actually use this to help automate that. I'm actually going to show that in a moment. If you've got a malware analysis workflow and you're looking to automatically capture indicators directly from IDA or some other malware analysis tool, if there's a Python interpreter in there, or some sort of SDK you could hook into, you could use this to automatically capture indicators that an analyst is identifying while they're reversing a sample. And then when they're done, they could generate an IOC right away. They can hand that off to your SOC people doing your active defense, or off to your investigators to do investigation, so that the investigators don't have to sit down and read your report and, okay, how do I move this piece of information in a report and write it into an IOC? The malware analyst has already done that for you. Actually, I do have a demo here to show. Verizon Wireless last year released a text scraping tool to extract IOCs out of unstructured text. I went ahead and added OpenIOC 1.1 support to that. And it took about an hour of working with their code and with the iocwriter code to add in the support. But what we have here in highlighted fields are fields that their software has identified as indicators. So they identify hashes, DNS names, email addresses, full URIs, and we can export that to OpenIOC 1.1. So I'm actually going to export that to a location on disk. So all those fields that were highlighted in this text scraper got exported. Just go ahead and open this directory back up. And we should have this IOC created. So we have on the right, we've got all the file hashes, we've got the IP addresses that were in that report, email names, DNS names. So all those things that might be useful that were previously unstructured, we can extract and we can start to add context to. And we can take those things that were previously in an unstructured text document, and we can start to deploy those in our endpoint solutions or in our network monitoring solutions. Clearly, this is a limited set of information that's available right now. I didn't go through and try to add more types of text fields to extract, but the possibility is there. So Yara. So how many people here are familiar with Yara? Fairly common. So effectively what Yara is a way to define strings, hex strings, or other rules. Yara can compound rules together for identifying malware samples or classifying files. And you're combining all these rules and expressions together in a Boolean fashion. This is very straightforward and similar to what OpenIOC does, but instead of using just pure strings to identify files on a system, OpenIOC has lots of terms and looking for different things. But the similarities allow us to actually embed Yara in OpenIOC. And you might wonder, well, how do you do that? Yara's got a lot of different keywords, whereas OpenIOC doesn't have as many keywords to define these indicator items. Well, that's where we can use parameters to extend the functionality of OpenIOC if we wanted to embed Yara signatures within it. So the real trick to that was figuring out how to store all the parts of a signature sanely and turn around and extract that signature out of the IOC so that it could be deployed. Talked about implementation, some of the additional modifiers. With OpenIOC, we can define a term. We can define that type of operator and a match with contains or is. However, we don't have the concept of a Unicode or a wide string versus an ASCII string. Case sensitivity is built into OpenIOC 1.1 now. There are some additional Yara things that are not tied to operators themselves, but to the conditions. We also had to use parameters for that as well. So when we go ahead and we want to generate a Yara signature, we would have to walk the IOC tree. And this is where recursion is really your friendly tool here. And this is actually, this code right here is generic to almost any OpenIOC processing code, where you have some function where you're walking down an indicator. And you do some pre-processing on the node that you're at. And then you do some dependency based on whether or not your current node is an indicator, meaning there's going to be some branching logic, or if it's an indicator item node, meaning there's actual intelligence that we want to act on here. In which case, if it's an indicator, we recurse. If it's not an indicator, we extract the intelligence however we need to. When we're done, we do some post-processing. We just have to be very smart about how we walk this recursively to make sure we don't end up in any nasty problems. With that approach in mind, having defined some of the parameters for Yara, was actually able to support about 90% of the Yara specification in OpenIOC. Some things were just not supported due to time constraints. Some things get a little bit more complicated than what I was trying to do in my simple example. But again, this was an example of how we can use OpenIOC and how we can use parameters to define more than just those hard defined list of terms that we publish on our website, openioc.org. So I want to do a quick example here. So everybody remembers the Dooku malware family? As one of the spin-offs of Stuxnet. So we've got an OpenIOC here that one of our malware analysts came up with. And I went ahead and grabbed a bunch of Dooku samples from some publicly available sources, and I wrote Yara signatures for those. But instead of storing them in just a Yara file that you're only going to see being consumed by a Yara compiler, I went ahead and I stored that in the OpenIOC format. I'm sorry that I can't zoom this application any bigger. I mentioned parameters earlier. I'm sorry for people that are in the back that can't see, but there are some screens on the side. On the right, there's a properties pane though, and we have a parameters set. So people that are familiar with Yara, you're aware that, yes?
There's an application that does full magnifier.
You're right. You win. You need a beer, sir. Thank you. So people that are familiar with Yara, some of the ways you can write conditions is you can say, pick 3 of the 5 items. So effectively you're picking 3 items from a set. So we can apply parameters using the indicator editor, or if we were converting these automatically, we could add those parameters with a machine. But we can add these parameters in to specify some matching criteria. So on this AND operator over here, this guy right here, since it's saying a Yara set, I want to pick 3 of any of these 4 items for a match. And it's also being ORed together with any of these guys. If anybody that remembers Dooku remembers, these were some of the names of companies that had stolen certificates that were used by the attackers. I'm going to go ahead and come out of this for a moment. So we have these IOCs. All the example IOCs that are included in the library actually map back to examples in the Yara documentation. If you wanted to see how OpenIOC implementation of the Yara rules would look like. So I'm going to go ahead and convert these, again, real time. Let's hope this works. I'm going to convert these to a Yara signature, and then I'm going to match those against some files. I can, just a moment. Okay. There. Good. There we go. Yeah, this is driving me insane. Welcome to NoVA Hackers. This is also a comedy hour for the day. Really. Anyhow. So we specify the input, some example IOCs, and the output's going to write it by default to iocs.yara. Oops. Okay, so we went ahead and converted that. Where is the output? Actually, it wrote it out to test as a directory. So we have our rules. So all of the IOC metadata was also captured in this Yara conversion. So we have the author information, we have some descriptive information, we have the original ID of the indicator that it came from. We have all of the strings that were embedded in the IOC. And then what we have, unfortunately, is kind of a really big, nasty condition that gets generated. For anybody that's written Yara by hand, you have very nice identifiers to identify all of your strings. With OpenIOC, we actually use GUIDs for our unique identifiers with our indicator editor by default. There's nothing that's preventing somebody from having human readable and human friendly indicators, indicator IDs. It's just convention with the editor tool that we use. So there's probably some other examples looking for strings existing in different locations and files. This was derived from that OpenIOC. So by those indicator items and the parameters assigned to them, we were able to generate this Yara rule. Now if you want to go ahead and match it, let's see if this drives me insane again. Okay. So we have a quick script to test a Yara rules against a set of files. So I tested those against a bunch of example files that are distributed along with the repository. So we have a couple of different rules that matched on a couple of different files. So a lot of these are just examples just to show that the rules can match. But you could go ahead and you can expand this out to all of your malware samples, however you want your Yara rules to look like. Again, this is a proof of concept demo. So an example of taking an OpenIOC, converting it into something useful that we can actually deploy, and then deploying it with our tools that we have at hand. Yes. Sorry.
So, go ahead. Go on, sorry.
Do you have, so you can convert, it looks like both ways, to and from Yara. and to and from OpenIOC. You said earlier that I think that there's some data that gets lost in the transition from one to the other. Like, how much is lost if you go from OpenIOC to Yara back to OpenIOC? Like, is it still functionally the same, or is it just like Google Translate from Russian to Klingon to Spanish back to English, where it makes no sense?
So to clarify, I don't have a way to convert from Yara to OpenIOC yet.
Oh.
I've looked at doing that. I'd have to re-implement the Yara grammar because the grammar is actually specified in the source code. The grammar is not actually formally defined anywhere else.
Like BNF? Okay.
It's in BNF in the source code for libyara.
Oh, okay.
That said, it's not impossible to do that conversion. There are certain things that we can do in OpenIOC that we can't do in Yara. So for instance, we define the GUIDs with dashes. Those dashes are illegal characters in Yara, so we have to strip those out. So if you were to go from OpenIOC to Yara, then back to OpenIOC, you could have a conversion that would be lossless at that point. Some things like white spaces are not allowed in identifier names in Yara. So whereas we might use white space as the name of an OpenIOC, that white space wouldn't be preserved in a translation over to Yara. So the Yara rule would say OpenIOC like Dooku __ backdoor. Whereas in the IOC, that's white space characters.
But functionally, if you did, it would be, you think, the same?
Yeah. One thing to consider is that we're only extracting parts of the IOC that were defined as Yara terms. So we're not extracting the file hash. We're not extracting registry information. We're not extracting process information. So in that case, you could have some loss. I believe there was another question.
Yeah, so actually it's somewhat related. You had mentioned, I think, that in your initial conversion, you were able to sort of preserve the logic of about 90% of the Yara signatures you could bring into IRC and then spit back out as usable Yara sigs. And you also pointed out that there's some logic that Yara sigs can have embedded in them that OpenIOC didn't quite have. So it's like the 304 kind of thing.
It's a set operation, effectively, yes.
Yeah, so is that informing you? There's also kind of a question, Doug. Is that informing you guys about like maybe that and other, and Yara is just one example, of other things you might want to add in maybe IOC 1.4?
So that's why we came up with the parameter section. We've sort of had this as a going roadshow since we released it at the end of 2011. Everyone's had that, hey, you added that one thing. Yeah. And the problem is, if we added in the one thing everybody wanted, our schema would be this big and everyone would only be 5% of it. So what parameters allow you to do, and we'll just prove here, is if you want to add in that set operation, you can do it. You basically doing it with parameters. So the parameters basically allows us to assign the metadata, but you can also write your own application, organization, or other specific logic and add functionality to OpenIOC. So it's kind of a crazy Wild West idea, but at the same time, there's the standard of what's respected, and then you need to prototype what you need and try it out. And our hope is with releasing this and saying, hey, people give us comment, and making more available tools, is that people will look at it and they'll play with it and they'll find a use and they'll build a tool around it. And suddenly, if they tell two friends and they tell two friends, etc., we'll find something that like whenever we do 1.2, we'll actually build that in schema that's appropriate. And honestly, some of these things may be appropriate never to have in the schema. But yeah, so like we don't know what comes next, but we're hoping the community will help inform us. And you can pretty much build any of it in parameters right now and test it out.
So where's Liam to pitch building a bro?
So just
When his wife and you are baby.
so I mean I've got Mir. I use OpenIOC, but I'm kind of curious. I mean, how afraid are you of the industry adopting being able to use parameters and then everyone has their own unique thing? Like, it's kind of like the problem that Android supposedly has where it's getting fragmented, and now Google has come around and said, no, we're going to make everything like through this one app that solves all the problems. So how much has the community adopted parts of OpenIOC? You mentioned a couple vendors who are supporting importing the data.
Yeah.
So has anyone actually supported opening IOC and importing it correctly, retaining all of the stuff besides Mandiant? I mean,
No, so that's the problem, is other than the fact that few people credit with some open source tools, the commercial vendors are still having it behind. One of the other reasons we put this in there is a lot of people come to us going, our managed, so a few years ago, everyone's like, oh, that's nice. Now everyone's like, management's telling me I need a standard tomorrow. What can you give me? And they're like, my requirements are X plus Y plus Z. In a lot of cases, OpenIOC is X plus Y plus half of Z. They can make up the other half of Z and do what they need. And as I said, yes, people could write stuff all over the map, but my goal is to get it so that if something becomes really popular, we'll get more community buy-in, and then we can say in the next version, this is now part of the standard that we need. A lot of standards get written by people who are academic views who are just like, let's write everything.
Yeah.
We're much more agile in terms of we're building it as we need it. We're hoping this is the way people can show us what's useful. And sort of put your money where your mouth is. You build something that works, other people start using it. We'll happily consider putting it in there. So we get more useful in the product. I hope so. I mean, it's been very useful for us. Our goal is open source things to make it useful for other people. I think that's working over time.
Yeah. There's a short list of things that are supported and not supported. All of that is documented on the repo, the README for this. This slide was supposed to be gone. I tried to do snort mapping. Snort mapping did not work. Apparently snort admins really like their signature IDs, and mapping those on the fly was not happening. And we have the ability to downgrade. I mentioned that. I'm not going to go into some detail here. It's lossy because we have the ability to express more in 1.1 than we can in 1.0. People have questions. I'll be around the room. We'll be here. Me and Doug will be here for a little bit. Everything is up on our public-facing GitHub. So both Mandiant's iocwriter and the OpenIOC 1.1 draft specification and all of the supporting documentation for that is available there. If anybody has any questions, we'll be around, and there's some contact information on GitHub for us as well. Thank you guys very much.